Hi guys, welcome back. In this video, we are going to learn programming in C for BE CSE students based on the VTU 2025 STEAM first semester. Please take a moment to check the subject code on the screen. Today we'll be covering important questions from Module 5 which are very useful from an exam point of view. Also, save your time, I've already shared a free PDF of Module 5 important questions with answers in the description below. You can download it. Let us start with the first question. The first question is, how is union different from structure? Give an example. Or compare structure and union in terms of syntax, storage, and uses. Both the questions almost have a similar answer. Before going to the answer, what is structure? A structure is a collection of variables of different data types, where each memory has its own separate memory. And what is union? A union is also a collection of variables of different data types, but all members share the same memory location. We need to write the difference between both of these union and structure with the differences like their keyword, their size, their memory, their syntax, and uses or applicability, and with an example for both of them. Let's start differentiating them. Keyword. Structure uses the keyword strut and union uses the keyword union. And now you can look at the syntax over here. The syntax is same for both of them, just the keyword on the first line is being changed. Now structure keyword is strat and union keyword is union. Now moving on to the next, size. This is the core concept. In a structure, memory is allocated for all members. So total size is sum of sizes of all members. In a union, memory is allocated only for the largest member. So total size of union is equal to the size of the largest member. That's why union is more memory efficient. Memory. In a structure, each member gets his own memory. But in a union, all members share the same memory. Structure, separate memory, and union, shared memory. Value altering. In a structure, if I change one member's value, it will not affect the other members. But in a union, if I change one member's value, it overrides the other member's value. Accessing members. In a structure, we can access all members whenever required. In a union, at a time, only one member is valid. Only the last assigned member holds the correct value in union. Initialization. In a structure, we can initialize all members at once. In a union, only the first member can be initialized at the time of declaration. Now, look at the example carefully. At first, both programs look almost same and even the output is the same, but the actual difference is in how memory is used. First, let me explain the structure. In the structure, each member gets separate memory. So, when I assign values to I, F, and C, all three values are stored at the same time. That's why I can print integer, float, and character together, and everything works perfectly. Now let's talk about the union. In a union, all members share the same memory location. So when I store the integer value, it is saved. But the moment I store the float value, the integer value is overwritten. And when I store the character value, it again overwrites the previous one. You might be thinking, then why are we still getting the correct output? The reason is simple. I am printing each value immediately after assigning it. That's why the output looks correct. But internally, only one value exists at a time in a union. So remember this clearly. A structure stores all values safely but uses more memory. A union saves memory but allows only one valid value at a time. That memory behavior is the real difference between structure and union. Now, let's move to the second question. Give the syntax for declaring and initializing a union with a suitable example. To declare a union, we use the keyword union followed by the union name. Inside the union, we define different members just like a structure. So the general syntax looked like this. We write union, the name of the union, then inside the braces, we write the data members and finally a semicolon. To declare a variable of union, we simply write union, the union name and the variable name. Now when it comes to initializing a union, remember one very important rule. Only the first member of a union can be initialized at the time of declaration. That's why the initialization syntax looks like this. We assign a single value inside braces and that value goes to the first member. Now let me explain the example. Here we have a union called data with three members, an integer, a float and a character. When I write union data d equal to inside the braces 10 semicolon, the value 10 is stored in the first member which is in the integer. So when I print the integer value, it prints 10. After that, when I assign 3.14 to the float member, it overwrites the integer value because all members share the same memory. That's why the float prints directly as 3.14, but the integer value is no longer valid. So remember this clearly. A union saves memory, but at any time, only one member can hold a valid value. This is the correct syntax and example of declaring and initializing a union. Now let's move to question 3. Here we are asked to develop a C program using structures to read student marks, calculate the average, and then display the students who scored above and below the average. First, let's understand the idea of the program. We are using the structure to store the information in this program. The structure contains only marks, but since we are dealing with multiple students, we use an array of structures. Now in the main function, we first ask the user to enter the number of students. Then we read the marks of each student for loop using a for loop. While reading the marks, we keep adding them to a variable called total. After reading all the marks, we calculate the average marks by dividing the total by the number of students. Once the average is calculated, we again use a for loop to compare each student's marks with the average. If a student's marks are greater than or equal to the average, we display that student as above average. Otherwise, we display that student as below average. Finally, the program prints the average marks and clearly shows which students are above and below the average. So this program demonstrates use of structures, array of structures, calculation of average, and conditional checking using if else. This type of question is very common in exams, and if you write the program step by step like this, you can easily score full marks. Now let's move to question 4. The problem says that a local library wants to store and display details of its book like title, author, and year of publication. So, the first thing we need to think about is how do we group all these related details together? For that, we use a structure. Here, I have defined a structure called book. Inside the structure, I have three members, a character array for the title, another character array for the author, and an integer for the year of publication. Now, since a library has multiple books, a single structure variable is not enough. So, in the main function, I declare an array of structures which allows us to store details of many books. Next, I ask the user to enter the number of books. Using a for loop, I read the title, author, and year for each book and store them in the structure array. After all the details are entered, I use another for loop to display the list of books. Each book is printed in a clear format showing the book number, title, author, and year of publication. So overall, this program demonstrates how to define a structure, how to use an array of structures, how to read and display structured data. This is a very common real life application of structures. And in the exam, writing the structure definition and using loop like this can easily help you score full marks. Now, let's move to question 5. The question asks, what is a structure? And to explain the C syntax of structure, declaration with an example. First, let me explain what a structure is in simple words. A structure in C is a user-defined data type that allows us to store different types of data together under a single name. For example, if I want to store details of a book like title, author, year, and price, all these values are of different data types. Instead of using separate variables, we group them together using the structure. Now, let's look at the syntax of a structure declaration. We start with the keyword strut followed by the structure name. Inside the braces, we declare the data members and finally we end with a semicolon. After defining the structure, we can create variables of that structure type. Now let me explain the example. Here we have a structure called booklist. It contains a character array for author name, a character array for title, an integer for year, and a float for price. Once the structure is defined, we create structure variables like B1 and B2. These variables can now store complete details of two different books. So to summarize it, structure helps in grouping related data. It can store heterogeneous data types. It makes programs more organized and readable. This is the correct definition, syntax, and example of a structure in C. And this question is very important from an exam point of view. Now, let's move to question 6. The question asks us to describe a method to compare two structure variables of the same type and also give a simple example. First, let me explain the concept clearly. In C, we cannot directly compare two structure variables using operators like equal to, assignment operators, or exclamatory mark equal to, not equal to. This is because a structure contains multiple members, not just a single value. So, the correct method is we compare each data member individually. If all the members are equal, then we can say the two structure variables are equal. Otherwise, they are not equal. Now, let us understand this using the simple example. Here we have a structure called student with two numbers, roll and marks. In the program, we create a structure variables and store values of for roll numbers and marks. To compare two students, we check the roll numbers and marks one by one using if conditions. If both the roll numbers and marks match, we conclude that the structure variables are equal. Otherwise, they are different. So the important point to remember is structure variables are compared member by member, not directly. This method is commonly used in exams and real programs, And writing this explanation along with a simple example can easily help you score full marks. Now let's move to question 7. The question is, define enumerated data type and explain its declaration and access with the C program. Let me first explain what an enumerated data type is. An enumerated data type or enum is a user-defined data type in C. It is mainly used to give meaningful names to integer constants. Instead of remembering numbers like 0, 1, 2, we use names which makes the program easy to read and easy to understand. Now let's look at the syntax for declaring an enum. We start with the keyword enum followed by the enum name, and inside the braces we list the constant names separated by commas. By default, the first constant gets the value 0. The second gets 1, the third gets 2, and so on. After declaring the enum, we can create a variable of enum type just like we create variables of other data types. Now let me explain the example program. In this example, we define an enum called V, which contains the days from Monday to Sunday. Then inside main function, we declare a variable called day of type enum V. When we assign Wednesday to the variable day, internally the value 2 is stored because counting starts from 0. That's why when we print the value of day, the output is 2. So the program shows how to declare an enum, how to declare an enum variable, and how to access enum values. Enumerated data types makes the program more readable, and they are very useful when we have fixed set of. Now let's move to question 8. The question is to develop a C program that shows how to access and modify the members of structures when we are using an array of structures. First, let me explain the idea behind this program. We have a structure called student which contains two members, roll number and marks. Since we are dealing with multiple students, we don't create just one structure variable. Instead, we create an array of structures. In the main function, we declare an array called yes, which can store details of three students. Now to access the members, we use a for loop. Inside the loop, we read the roll number and marks of each student. Using the dot operator with array indexing, for example, yes I dot roll accesses the roll number of I student. Yes I dot marks accesses the marks of I student. If we want to modify any value, we can directly assign a new value to the member using the same notation. After reading and modifying the data, we again use a for loop to display the student details. So the program clearly demonstrates use of a structure, use of an array of structures, how to access structure members, and how to modify and display them.